In this video, we will look at the idea of database normalization. Normalization means that we are going to analyze our schemas, we are going to analyze our relations, and try to minimize the data redundancy and any inconsistencies that could happen if we update, modify, or delete, or even insert data to our database relations. So in this part, we will look at some informal design guidelines for our relational databases, and we'll look at some of the anomalies that could happen in result of bad design. We will look at insertion, deletion, and modification anomalies that could be a result of a bad relational database design. So as you may recall, when we are designing our relational database, we are basically grouping a set of attributes to form relation schemas. So the result will be a set of relations, a set of tables, and that will be our relation schemas. Now our relation schemas, we have two levels for them. One level is the logical level or conceptual level, which is how the user interprets and views the relation schemas and the meaning of their attributes. The other level will be the storage or base relation level, which is how we are physically storing our data in our tables, how we are physically storing our tuples, and how we are updating them in our system. So we are mainly our main concern here is the base level, how we are going to design the base level, which is how we are storing our data. So we want to find the criteria or the guidelines to have a good base relation level design. So what is a well-structured relation? What is our goal? We are trying to minimize the data redundancy. We do want to keep the data redundancy at a minimal level, and we want to allow the users to insert, delete, and update rows or tuples without causing any data inconsistencies. Why do we want to minimize the data redundancy? The more data repetition that you have in your database, the more storage that you will need, which is basically wasting storage. So instead of storing the same data once, you are storing it multiple times. That will require more storage space for your database, and that's basically wasting your storage resources. Now, what could happen if we have this data redundancy? We might be getting these update anomalies. So we might get insertion, deletion, or modification or update anomalies, which happens because of this data redundancy. So our general rule of thumb here is we want to have the table only to pertain to one entity type. So we should not have more than one entity type stored in the same relation or table. So let's look at this example. I have here two tables or two relations. One is employee department and one is employee project. You'll notice for the employee in the employee department here, I'm storing the employee name, their social security number, their birth date, their address, and the department number, department name, and the department manager social security. Notice that the primary key I have for this table is the social security number. Now, you will notice that I have some repeated values here for the department number. So the research department, the name, I'm repeating it in this column 4 times. The administration, I'm repeating it 3 times. Now, every time I have the research department, which is department 5, I'm also repeating the department manager social security number. So if, for example, I'm using 1 byte to store the department name and 1 byte to store the department manager social security number, every time I have an employee that works at department number 5, I'm repeating these 2 bytes over and over again. So if I have 1,000 employees that work at department 5, I will be wasting 2,000 bytes repeating the same information over and over again. So I have some data redundancy in here where I'm basically repeating the same information. Instead, if we were using a good design guideline, if we had the department table that we are storing the department name and the department manager social security number, I would only need the department number in this table to be able to get the department name or the department manager social security number just by using the foreign and primary key values. So in that case, I would not need to repeat the department name or the department manager social security. I would only need the department number in this table, and I can get all this information from the other table. Another example here, we have a table called employee underscore project. We have the social security number and the project number as our primary key. So we have a composite primary key. We have the hours that this employee will be spending in this project. We have the employee name, the project name, and the project location. Again, we have the same redundancy. I can get any information I need about my employee using their social security number. I do not need to repeat their name in here. So I'm repeating every time I have this employee working on any project, I'm also repeating their name. So you'll notice I have this employee which is present in this table 4 times. And every time I'm writing their name again in this table. Same thing with the project name. If I have a project here, for example, product X, every time I have that project, which is project number 1, I'm repeating or writing the name again, which is product X. I'm also repeating the project location. So every time I have product X, I have the project location below. So every time I'm repeating the same information, which is a redundant information. So what we are trying to do in our design or good design principles, we want to eliminate that data redundancy to help improve the storage efficiency of our database. Let's look at another example where we have a problem with the update anomaly. So let's say we have this table. This is the only table we have. We have an employee social security number, the employee name, the project number, project name, and the project location, and how many hours the employee is going to spend on that project. Now, in this case, if we needed to change the name of the project number 2, instead of naming it product Y, we want to name it to product A. Now, if we had another table that is called project, and we did not list the project name and the project location in here, we only needed to change that name in one row. However, in this table, we will need to go to all the rows that have project number 2, which is project 2 here, and we need to go and change the project name from product Y to product A. So if we had 100 employees working on that project, we will need to go and update 100 rows or 100 tuples instead of only updating one row if we had the information only in the project table. So the problem here is called, again, update anomaly. When we are trying to update a project name for this project number, so project number 2, we wanted to update the name from product Y to product A. In this case, I will have to go to multiple rows that have product or project 2 in as a project assigned to that employee, and we will need to update the project name for each one of these rows. Now, another problem we could have also with this redundancy is the insert anomaly. Since we have a composite primary key, we do not have a single attribute as our primary key, because the social security could be repeated and the project number could be repeated, because we might have multiple employees working on the same project, and we can have multiple projects assigned to the same employee. So this employee is working on project 1 and project 2, and project 1 we have this employee working on it. So we have a composite primary key. The problem will happen when we try to insert a new project. Let's say we want to insert a project with the ID 50. Now, I cannot insert the project 50 unless I have an employee assigned to that project, because we cannot have our primary key or part of our primary key as null. So if I do not have an employee assigned to project 50, I cannot insert project 50 into my table. Same thing with the employee. If I have a new employee and I want to add them to this table, I cannot add that employee to the table unless they have a project assigned to them. So that's what we call an insert anomaly. We have an inconsistency when we try to insert new rows or tuples to that table. We need to have an employee and a project assigned to that employee if we want to insert that employee. Or if we are trying to insert a project, we must have an employee assigned to that project before we are able to insert it to this table. The other type of anomaly we can have also is the delete anomaly. Now let's assume we want to delete project number 20. When we delete project 20, we are basically deleting all the rows associated with that project. So we'll delete this row, and this row. Notice the employee James here is only working on this project 20. So when we deleted project 20, we basically deleted James from our table. So we do not have James anymore in our table. On the other hand, let's say John here is not working in our company anymore, and we decided we want to delete John from our company. When we delete John, that will result deleting all the projects he was assigned to. So if there was another employee working on that project, we do not have a problem. But if John was the only person working on project number 2, that means we do not have project number 2 anymore in our company. So let's say that we have John and Joyce quitting our company. So when we deleted John and Joyce, we deleted their rows. And basically, since they are the only employees working on project 1, we do not have project 1 anymore in our company. And this is what we call a delete anomaly. So if we deleted a project, it would result deleting all the employees who work on that project. And if we deleted an employee, that will result deleting all the projects that were assigned to these employees. So let's recap these informal guidelines that we discussed so far. The first guideline we have is we want to have each tuple in a relation should represent only one entity or a relationship instance. So like we had before, the employee table should only reflect or have attributes for the employee. It should not have attributes for other tables. Same thing with the project table. It only has to have information about the project. If we want to have information about employees, or for the employee we want to have information about the department, we only need one column, which is the foreign key, to map to the department table. So a table should not pertain to more than one entity type. Another guideline we discussed is we want to have a schema or design a schema that does not suffer from these anomalies, the 3 anomalies, the insertion, deletion, and update anomalies. And lastly, we also want to have a design where the tuples will have as few null values as possible. Having more null values means that you need to move these columns into a different relation to minimize these null values in your design.